Welcome back to 2022. This is our first video of the series. In my hand is a tong tester, and every single person that works with water or electricity, or whether you're finding leaks, should have one of these. I'm going to make 3 short videos. This first video is if you're a leak detector or you work with hot water cylinders and you want to know if the element and thermostat are working correctly, and we'll focus just on that, and we'll do a short, quick, sweet one just about using this with a hot water cylinder. The second video is if you're a utility locator and how do you use this to trace your drains and to trace pipes. Then the third video we'll do is we'll go to our DB board behind us over there, or behind Colin, and I'll show you how to use this to right size your solar system for your house, and how to use an ammeter or a clamp meter or a tong tester to right size for your house. So let's get on to the first video. Is about leak detection and geyser maintenance. If I've got a leak on a system, it's either on the hot or it's on the cold. If it's on the hot water, because you've done a pressure test, and the video is not about how to find the difference, but once you've determined if it's on the hot water, it's your duty to switch off the geezer's electricity. But you don't always want to climb up into the ceiling, so you go to the DB board and you flick the switch down. And there's a little trick that we're going to show you how to see what size is the geyser by determining the size of the element with this device. Without getting into the ceiling, you can see the size of the element. So let's go straight to the geyser that we've installed. The second video will be focusing on utility location. So we've got a little cylinder installed here. If you will find faults, I found 1 or 2. We'd love to get your comments, and the guys that are coming on the training in January and February can give the comments on it. But let's get stuck into it. So the first things first is I've isolated this geyser and the power is off. So in your bag you normally have a set of leads and you have a tong tester, and then you also have a thermocouple. So what I want to do is check for voltage first. So you'll put your leads in for voltage, and my advice is to buy a true RMS tong tester, and this tong tester can check DC and it can check AC. The reason why you want a true RMS is if you're going to start doing variable speed drives with pumps and you get called out to look at all sorts of installations, the true RMS doesn't just average, it gives you the true amps. So the first things first is, how much volts do we have in South Africa? 220 volts. This tong tester will work in the States as well with 110 volts. You're just going to have double the amps. So the first things first is we're going to switch the isolator on. I've just switched it on, and I'm going to put my terminals on the black and the red, and I'm going to put it on, and we're going to see that we have got 215.2 volts, 215 volts. So in South Africa, you're not going to get pure 220 volts. So I want to show you on the calculator. We'll simplify Ohm's law, and on my calculator over here, we say that you're supposed to have 220 volts, and we say 3,000 watts because this is a 3 kilowatt, and most of you are going to be working on 3 kilowatt elements in South Africa. So you say 3,000 watts divided by 220 volts gives me 13.6. So if I want to know if this element inside here is functioning correctly, according to Ohm's law, it should be giving me approximately 13.6 amps. I want you to think of amps as flow rate. So this thing now becomes like a water meter. It's not a pressure gauge, because the voltmeter is your pressure gauge. Think about volts as pressure. So we put the volts on there, and we're getting a volt of 214 volts. So it's 6 volts under what it should be. But when I put the tong around it, and there's a coil on here, and when I put a cable through here, this thing starts measuring the flow of electricity, or amps, and named after some French dude called Ampere. So what you do is you put the clamp meter around either the black wire and check it's reading 12.3. But if I move, you see those little indicators there, you can see there's a stripe on there. That's actually the optimal place for it to be. And if I move the tong tester up, I get 12.8 amps. And if I bring it down, I'm getting 12.3 amps. So please guys, it's not an exact science. It's just for you as a plumber to say, it's a 3 kilowatt element. It's approximately 4 amps per kilowatt. So 4, 8, 12. But it's a little bit more than 4. It's 4.5. So it's 13.6 according to the calculator. So I'm getting just under 13, which is telling me that, remember there I'm getting 13 now. And remember, we're not getting pure 220 volts. So don't be very strict with this. Now watch what happens when I clamp this around both the red and the black. It cancels it out, and look at the reading. It's 0.008. Now the reason why you're getting some stuff is that there's an electromagnetic field here that's interfering. And when we do the next video on utility location and how to use this baby to find drains and to find things, then you'll see that understanding the flow of electrons is incredible, because it opens up your mind. Because as a person working on a geyser, and please, I'm not at all saying that plumbers should be electricians. We are merely doing diagnostics. You are merely diagnosing. You are not doing an installation. You're not rewiring anything. You're merely diagnosing your cylinder, and you say, I've got a finger on the pulse of this cylinder. I know. Think of it as a water meter. I know the flow rate, because the voltage is the pressure and the amps is the flow rate. So now we put it around the red wire, and I'm getting 12.1, 12.4. It's vacillating, it's jumping up and down. And I put it around the black wire, I'll get the exact same, 12.4. And now here's a very interesting thing. At Eskom, they've got these huge big generators. And the beautiful thing about electricity, it's almost like spiritual, because everything works in this perfect circle of 360 degrees. So there's 3 points at every 120 degrees on the generator, whether you're at Koeberg Power Station, which is nuclear powered, or which is Letaba Power Station, where we're relining, which is coal fired. You still got a 360 degree generator, and every 120 degrees comes one phase off this thing. And 120 times 3 is 360. The harmonics of electricity is absolutely amazing, and we will look at it in the utility location video of the harmonics and how to understand how current flows through conductive items. But I'm going to put this into hertz, and I've set the hertz. Let's take, this is a brand new ammeter. Take that little thing off. Can you see the hertz there? It says hertz. And I'm going to put this onto the thermostat to get power and get a proper connection. And there you have it, 50 hertz. So what you're getting is 50 hertz and 12 amps. But if we move it up a little bit, we'll get a better, we get 12.4 amps. And if we change this to volts, then you can see that you've got 213 volts and 12.5 amps. Look how much information you've got on this device now. Now you know that you've got 50 hertz. In America, they've got 60 hertz, which means that the magnet in the generator has a north pole and a south pole, and every time that magnet changes poles, you get this not explosion, but this expansion and contraction. That's why it's called alternating current, because the power is going forwards and backwards and forwards and backwards. And in our utility location video, we'll talk about alternating current, and you study it on the course. So every time the magnet at the generator changes polarity, you're getting this expansion and contraction of the electrons and the neutrons, and you're getting 50,000 cycles per second, and those harmonics can be traced. This simple little device will tell you. So what you do is you go to the DB board and you find the circuit breaker and you find the Giza circuit breaker and you put this around the clamp. Let's say you closed the ceiling up already and you say, I wonder if that Giza's working fine. Did I remember to turn it on? Hold on, let's see. And you can actually see if the Giza, if the thermostat's kicked in or kicked out, or if still, you can actually see how many amps it's pulling. So if it's a 4 kilowatt element, you're probably going to be pulling between 16 and 18 amps. If it's a 2 kilowatt element, you're going to be pulling at about 8 to 9 amps. If it's a 3 kilowatt element, you're going to be on average 12, 13, maybe if you've got extra voltage. I mean, just now, about 2 hours ago, I was measuring 230 volts here. So this is not pure sine wave, perfect stuff that you're getting. But I thought that will just be a very cool little introduction. And I would send all my teams out with one of these. I wouldn't let them do a hot water cylinder without checking that it's actually drawing amps. Flow rate. Next video we will do on utility location. Thank you.